Hi guys, in this video we will be looking at trigonometry. Grade 11, and even if you're not in grade 11, there's always a room for learning, because as we all know that learning is infinity. Well, if you're new to this channel guys, what are you waiting for? Do the right thing, subscribe, like, comment, right, and share. That will be highly appreciated, right? So without wasting time, let's get to today's video. Firstly guys, I will remind you of a very important part, which is a CAS diagram. We all know that it's essential to know a CAS diagram, right? So this will be 90, 180 degrees, 270, as well as 360, and there's 0 degrees. All students take coffee. That's how I remember it. And all trigonometric ratios are positive. Yes, so the second quadrant, sine is positive, but the other trigonometric ratios are negative, right? Such as cos and tan. Then here, tan is positive, but the other trigonometric ratios are negative. Here, cos is positive, and the other trigonometric ratios are negative. So today I want to also much on the reduction formulae. We will look at it as we, in this series of trigonometric grade 11, we will look at it as we go further. So it's very essential that you listen carefully. Then we will look at questions that involves a CAS diagram. So let's consider if sine, let's say sine theta is equals to 2 all over 3, and we are being told that theta is the element, then open the bracket, 90 degrees and 270 degrees. Okay, is that the restriction that we're given? Then they said determine, and the question requires us to determine the value, sorry, let's determine the value of sine squared theta. Let's say they said sine squared theta plus cos squared theta. Then they will say, I'll use another word again, they will say without using the calculator. And I just say without using the calculator. So with this type of question, guys, you have to draw a diagram in order to solve the value, right? You have to draw the diagram. That's the first thing. Yes, with this type of question, you have to draw the diagram in order to solve the value of sine squared plus cos squared theta. Step 1, our first step, we have to determine which quadrant theta is in the diagram. I hope you're noting. Firstly, determine which quadrant theta is in, and then you will draw the diagram. Well, by the look of things, if you check very well here, what are we given here? Sorry for the background noise. What are we having here, guys? We're having sine theta, which is 2 all over 3. You're given sine theta, which is equals to 2 all over 3. 2 all over 3, it's positive. 2 all over 3, it's positive. What does that mean? Therefore, it means that theta lies between quadrant 1 and quadrant 2, because this is where sine is positive, and this is where sine is also positive. But the other quadrant, remember, this is quadrant 1, quadrant 2. Then what do? you are told, that theta is between 90 and 270. I won't rush, guys, because I don't want to crash. We are told that theta is between 90 and 270. This means that since we have said that theta is positive on the first, on the second quadrant, we will have to put ticks there. So how are we going to work out this? Let's start with the diagram first, then we'll talk after. Very important, because I don't want to rush, because at times when you rush, you crash. So we don't want to crash. So draw your cast diagram. Okay. So draw your Cartesian plane. Oh, sorry for that. We have y-axis and the x-axis. Right. Our theta will be here. Then when you draw, arrow will go this side. So let's draw. Okay. Someone will ask, Mr. Richard, why are you drawing this diagram on the second quadrant? Why not drawing it on the first quadrant? Right? Why not draw it on the second quadrant? Mind you, we said that this is where the diagram will be tick, and also on the second quadrant. These are the two quadrants that we are going to work with. This is where sine theta is positive, right? So guys, why did I put two ticks there? It is because this is where both constraints are satisfied. This is where both constraints are satisfied. What do I mean that? Remember, you are having sine theta. You're having sine theta, guys, which is equals to 2 all over 3. It's equals to y all over r. And your y is 2, your r is 3. Then if you use a theorem of Pythagoras, let's use to check what will happen here. This is x squared plus y squared, which is equals to r squared. And we know that we're looking for x squared. We need to know the y value there. We know that our y value is given as 2, our r is 3, so this is 3 squared minus minus 2 squared. Okay, then this is 9 minus 4, then this is x squared. 9 minus 4 is 5, then square root of this will be plus or minus root 5. So when you are here, I want you not to rush. I'll tell you why. And as I've said, so from here, why two ticks on the second quadrant? It is because this is where the terminal arm, talking about this theta, it lies on the second quadrant. That's why I put two ticks here. And this is where sine theta is positive. It is true that sine theta is also positive on the first quadrant, right? But where both constraints are satisfied, that happens on the second quadrant. I hope I'm clear in that, right? So let's continue the drawing. This is 90 degrees. Let's put this is 3, and our y value, which is 2, and we have negative root 5. I've done the part of finding the missing value, which was x. So from here you will have acquired some marks. You've obtained some marks there, and then you've obtained some marks. Now the real deal starts to get interesting. The real deal, which is remember, determine the value. We have not solved the question. Determine the value of sine squared theta plus cos squared theta without using a calculator. So which is our step 3. Remember, step 1, you have to put your diagram. Step 2, you gotta calculate the value of the missing values that are there. Then step 3 now, which is to find the value of sine squared theta plus cos squared theta. Do not, I know the common mistake that many learners do, they will just say, because it's given like this, let me just they will just say okay, sine is y all over r. We know that it's y all over r. Then our y is 2, our r it's 3. Then then they will say they will just say put sine here, sine, then they say squared plus they will just also say cos, then they put the value. We know that this is x all over our r, x all over r, our x is negative root 5 all over 3, then squared, then they said is equals to 1. That is entirely wrong. This is wrong when you do it like this. What is the correct way of writing it? Correct way of writing it, let's follow this. It's to put the trigonometric ratios, y all over r squared plus x all over r squared. In this manner, you will have written it. Remember, not looking for the values of thetas here. We're looking for the value of sine squared plus cos squared theta. So the best way of writing it is like, you're going to write it like this: y all over r squared plus x all over r squared. Then you substitute the values. Then what is your y? It's 2, your r it's 3 squared there. Then you have your x value there, which is negative root 5 divided by our r, it is 3 squared. Then we take it from them. Then we know that 2 squared is 4. Then we know that 3 squared is 9. Then we know that when you square this will be 5. Okay, this will be 5. 3 squared is gonna be 9. And we know that 4 plus 5 it's 9, and 9 divided by 9 it's 1. Yeah, then you will have written it very well. Then that's how you can get that beautiful mark. Let's look at our second example or activity that we can do so that we enhance our knowledge in this, right? Yes, I hope you are learning. Let's look at the second example. Well, the second activity or an example will be able to help us as well to enhance our knowledge, right? So if tan theta is equals to 4 over 3 and cos theta is less than 0, determine without a calculator the value of, firstly, sin theta all over cos theta. Second question, cos theta and tan theta. The first step here, guys. The first step, I won't rush, guys, as I've told you that I don't want to crash, because when you rush, you crash at times, right? So we'll just do it this politely, right? So first step is to determine which quadrant theta is in, right? Determine which quadrant theta is in and draw a diagram. That's the first step. So remember, let's look at tan theta. By the look of things, if you look at tan theta here, you can see that tan theta is positive, right? And we're being told that cos theta is less than 0. Something that is less than is negative. So meaning that cos theta is negative. And remind you, when they say tan theta, is positive, what does that come to your mind? What comes to your mind is that tan is on the third quadrant. And this is where tan is positive, right? But cos theta, this is where cos theta is also negative, meaning that our diagram will also be on the third quadrant. This is where we will put two ticks, right? So therefore, what about the terminal arm? The terminal arm lies in third quadrant. The terminal arm will lie on the third quadrant. Remember, as theta is in the is in the third quadrant. Yes, theta is in the third quadrant, and the values of x and y are negative. Why I'm saying negative? Let's put that into practice so that you understand what I'm saying, because I'm speaking a lot of theory there, right? So let's put it into practice. Here's your Cartesian plane. Okay, this is y-axis, this is x-axis. We'll place theta here. Then what about the terminal arm? The terminal arm will lies on the third quadrant. This is where tan is positive. So let me just put this. You're going to have a drawing like this. Use a ruler. Yours will be accurate. Remember, tan is positive on the first quadrant, but cos is negative on the second quadrant, right? I'm putting ticks now. So I told you that because we have tan theta as 4 all over 3, this is the same as y all over x, right? What are the values of y and x? The values of y and x are negative, meaning that x is negative 3 and y is negative 4. So when you divide them, obviously they will be positive. So that's why we have 4 all over 3 there. So remember, the values are negative. Why I'm saying so? Negative 3 will be here when you put it on the diagram. Then the y value will be here, will be negative 4, the y value there, right? So what is missing now is this path. So we have to use a theorem of Pythagoras to calculate it. X squared plus y squared, which is equals to r squared. So we now know that here there will be two ticks. There will be two ticks there. We're going to have two ticks. So that's where our diagram will be. So this is how you determine where your diagram will be. Check the given trigonometric ratio where it is positive. Check the x values and y values. That will also help you. Check where the terminal arm will be. You will be safe, guys. You'll be safe, right? It's better to be safe than sorry. Yeah? So I hope you are learning, right? So what are we looking for? We are looking for r there. So our x is negative 3 squared. Our y will be negative 4 squared, which is equals to r squared. Then we are working. 3 squared, it's 9. Then what about 4 squared? It's 16. And this will be 25. Will be 25. Then what is the square root of r? It's r square root of 25. That's gonna be 5. Remember, I cannot say plus or minus because r can never be negative. R can never be negative. So since r is always positive, since it is a length, so that's why I don't have to put negative on r, right? I hope you have understood what I was telling you here. So this is 5, right? Okay, I guess, guys, the issue of where will your diagram will be, it's solved now. It's a matter of understanding. It's a matter of checking where your trigonometric falls. Are they on the second quadrant? You don't just put two ticks and say, hey, and assume. No, check your values. Check. Remember, I said that for here to be our diagram to be on the second quadrant, I said that tan theta is positive on the third quadrant, and this is where cos as well is negative on the third quadrant. and therefore our terminal arms will lie also on the third quadrant. That was the reason of me putting 2 ticks. I didn't just assume, right? So let's put that into practice. Let's solve let's put solution on A. Remember that we are given sine theta divided by cos theta. So by the way, this is the same as y all over r divided by x all over r. Okay, so when you are working with this is y all over r, then the reciprocals tip times, we use tip times. This will be r all over x, right? Our y, what is our y, guys? Our y, we do have it. So let's look at our diagram there. It's -4. Our r, it's 5. Our r, it's 5. Our x, it's -3. So from by the look, this and this, they cancel. So we are left with -4 all over 3. That will be +4 all over 3. So the solution for sine theta all over cos theta is 4 over 3, which is similar to tan 4 all over 3, because sine all over cos, it's the same as tan. So it makes sense, right? So let's go to our last question, which is cos theta. We have cos theta and tan theta. Put your trigonometric ratio. This is x all over r multiply by tan, which is y all over x. And let's place our values there. We know that our x will be -3, our r will be 5, multiply by our y will be -4. What about our x? Our x is -3. So from the look of things, you can see that these two they cancel. They cancel, so we'll be left with negative and negative. It's +4. +4 divided by -5, because this will take a sign of a negative, so that will be -4 all over 5. The solution will be -4 all over 5. You can use a calculator if you are struggling with multiplication. So yes, yeah, yep. I hope I did make sense here. That's the end of it, guys. I hope this video has shed some light on you. Remember that for you to put 2 things, you don't just put 2 things. Check the given statement. It's what will guide you. The secret lies there in the statement, and then the statement will lead you to correct answers. I hope I've made some sense, guys. And if you're new to this channel, kindly subscribe. See you in the next video, where we'll be looking at identities, right? Well, in grade 11, you know, there are these 2 most important identities that we are focusing on, isn't it? See you on the next one. Take care. We love you.